Okay, so this is part two. Part one, somehow the computer froze. I was somehow able to save what I had recorded. Everything else, I couldn't do anything to the screen. So if you notice at the end of video one there, things weren't working right. So anyways, I'm going to finish part C, which should have been part one. Then we're going to get on to 1-4, the regression equations. But let's finish up question C. So what we were doing was, get the pen. We were just identifying A equals H equals B and K. But just like at least B, I think A even needed it too. But what we found was we had to get this into the parent function, the standard form. So we would rewrite that for f of, we can't have anything in front of the x, so I'm going to pull negative 0.25 out. Now it's x minus, but since we pulled a minus out of the x term, we actually have to say plus, and we can't just say 16, because if we have a coefficient out here of 1/4, 1/4 of 16 would really actually say x minus 4. So we actually take 16 times 4 briefly, and we get 64 minus 5. So what this allows is negative 1/4 times 64 gives us x minus 16, or negative 1/4 x plus 64 gives you the minus 16. So in the end, we now have standard form. We can identify our A is 4, our H is negative 64, B is over here, so B is, well, I'm going to put a negative out front. B, it's stretched by a factor, though, of, so we'll just write negative 0.25. We'll get to it in a little bit. That stretching by a factor of is going to be a little different. Our K is negative 5. So just simply identifying A, H is minus 64, B is negative 1/4, and K is negative 5. So the rules of our order of transformations says we need to go horizontal translations first. So we have a huge shift. We shift left by 64. So we've taken care of step one. The next step is any stretching. And we have vertical stretch by a factor of 4. We also have a horizontal stretch by a factor of, and here's where we would say 1 over absolute value of B is equal to 1/4. So the stretch actually happens by a factor of 4. It's 1 over 1/4. Do we have any reflections? We do. We have a reflection across, well, B is our negative. So if B is negative, we get that reflection across the y-axis. So our A is positive, so we don't reflect across the x. But last one, vertical stretch. So we'd say, yes, we have a shift down by 5. Okay, so we've got that. I'm going to just continue right on to question 3. Essentially what we're doing here is we're being asked, here's the age and then the amount of sleep required. So that's kind of like our x value. That's our fixed value, or our independent value. And then it's asking us to use the accompanying table, find the best model. So this is where we just plug in the data. L1 data goes, here is our age. Our L2 column is our amount of sleep. And then we would use the regression based on what our graph looks like from the data points. We would choose either linear, quadratic, exponential, and then we would actually get an equation or a model for the given data. So let's do that. This is our kind of my version of the TI-84 Plus. So I'll go ahead and show you how to enter data in just as a review. But the first thing, like I said, we got to put in L1 and L2 columns for our X and Y values. So to do that to add to our columns, we go here to stat, and then we want to edit the statistics. So if you do have data in here, let's say you've got some numbers in here, you've got some random, you want to clear it out. Easiest way to clear it out is go all the way to the top where it says L1, hit clear, and hit enter. It clears out your whole thing. So go up to the top, clear it out, hit enter. If, let's say, you might have a whole bunch of data, but oh, I accidentally had an extra 5 in there. I want to get rid of that 5. If I hit clear and enter, it doesn't do anything. It cleared all day long. It's not going to change it. If you want to change a certain cell or get rid of a few cells in a column, you go to the cell you want to delete. So in this case, let's get rid of 5. You actually come over to the delete key, you hit delete, and it removes that cell. If I hit it again, it removes that. So what it does is that specifically removes those cells. That's another way you could get by doing that. So let's enter in the data for this problem. All right, so you can see I now have L1, L2 filled in. We want to see what that looks like on our graph. So in order to do that, let's graph that. Let's just go to graph. Not super meaningful. What we do, get our graph perfectly aligned to fit on our screen. We go to zoom. And then down here, zoom stat is the best option. So you can arrow down to 9, hit enter, or just hit 9. And there's your data. Now, looking at that data, you can kind of see this little bit of a curve down and it's tapering off. If you think about the real world, you would never, your line shouldn't be linear, right? Because the older you get, it's not like you all of a sudden need negative sleep. So you do see how we would probably get 0 as an asymptote, or somewhere in close to 0. At the same time, we wouldn't have a negative age, so our data wouldn't go negative in the x-axis either. So there are some restrictions, and looking at this, we have to figure out what would be the best regression model. So in order to find an equation that best fits that, we would go stat, and then arrow over to the right one, and calc. Now here's all of our options. We can, again, there's your linear regression, probably not the best option. We'd have quadratic, maybe, but again, in real life, that would say that there's some point that once you hit a certain age, you then require more sleep again. So maybe that's realistic. Cubic, quartic, maybe it's a natural log or an exponential. So take a second, think about what kind of graph you think would best fit that data. I just had to do a quick check on the regressions myself. But what I found, if you're looking at the data, so here's our graph here. Quadratic looked okay. I'm just trying to save time on my video here, but if you go and test, so I'll do 2 tests. If you want to check an equation, you hit stat. You go over to calc, which is I think where I left the video off when I paused. If you want to try a quadratic and say maybe it will eventually come back up, we can test that. You hit enter, and then you hit enter about 4 more times. You're just checking to make sure your lists are correct. And you hit enter 1 more time, and it calculates an equation. Your R squared value is that value you want as close to 1 as possible. And a 0.98 is actually pretty good. Typically, a 0.98 is not bad. But what I found is, if I go back and hit stat and calc, and instead of quadratic, I chose, because I know what the graph of a natural log function looks like. In fact, it looks like this, so let me close that out. It looks like that, and that kind of looks like our data, but we want to shift it up. Now, just so you know, that's the opposite of natural. Here's your parent function for natural log. But, you know, if you flip that around, that looks pretty close, and then maybe we shift it up a little bit. So anyways, that's what I did. I tried it in natural log regression. So you hit enter a bunch of times. And what you find is your R value is actually 0.99, so it is actually a little better. So let's use this as our function. And how do we copy and paste that? Well, you can write it down, take a piece of paper, copy down your A, your B, go to y equals, type it all in manually, or shortcut is your copy and paste method. So that starts with a vars function here, your variables button there. And we're working with our statistics still. So we hit 5. We don't want to punch in variables. We want to go over to an equation. We want the regression equation. So what we're going to do is we're going to go hit enter, and it'll paste exactly that entire function. Now, if we were to hit graph at this point, it looks pretty darn good. It hits most points, and if it doesn't hit it, it comes very close. So, to answer the question on the problem, use the accompanying table to find the best model. The best model would then be that equation, and in our case, that came out to be y equals 14.79 plus negative 2.13 ln of x. So once we have this equation, part B says find the nearest hour the number of hours of sleep required for 35-year-old. So if we look at our graph, our data points, we don't have 35 in here, so we don't know. But if we look at our equation, we should be able to trace and find when x is 35, because x is our age, we should be able to get our y value. Now at this point, if you look up here, we're tracing, but we're tracing the plot. And so if I were to try and move, my data points are what I'm tracing. So I can't find 35 exactly. Trace anything else that you have on your graphing window. All you do is hit the up or down arrow. So at this point, now I can go to decimals of ages and so on. So as I'm tracing the function, I want to know at 35, when x is 35 years old, it says that a 35-year-old, theoretically, a 35-year-old should need 7.2, because it says to the nearest tenth of an hour, 7.2 hours. So we go back to our, whoop, wrong one. If we go back to our function here, it says plug it in and find the nearest tenth. We find 7.2 hours is needed. One other thing you can do to kind of check your work is double check. Well, a 25-year-old needs 8, 50 needs 6. So we can at least narrow it down to, you know what, 35 years old is between these two numbers. So looking at the trend, the number of sleep should fall between 6 and 8, and we find that it does. So question 2, or problem 2 here, same idea. It's based on the temperature it is outside, the number of soft drinks, number of cans sold, is, he believes, is correlated to the temperature. So the same thing's going to happen. We're going to put in our data in L1 and L2. We're going to look at our data, look at a regression, and then it says use the model to predict sales if the temperature is 95. So the same exact method, but it's going to be a different equation. So if you need, rewind the video, use the same steps, but instead of natural log, most likely it's going to be something different than that, maybe even linear. Okay, but then you'll answer the same questions below. Question 5, investing money, same things. Your X's are in your L1. Your value of the stock in dollars is your L2. Same thing, find the model. So go ahead and plot it, graph it, using the regression, the stat calc, rewind the video if you need to, and then using the model to predict a number of years. So again, you'd find the value at $100 or $1,000. So you would just use that trace function to get as close to 1,000 as you can to predict the number of years. That's it. Good luck.